Hello, welcome to a new video. Today we're going to do this problem called unique paths number 62. It's a problem LeetCode. It's a medium problem, and I did solve it. Well, I didn't solve it on my own. I had help, obviously. I remember doing this problem back in 2019. I was very new as a programmer. I didn't know no, it wasn't 2019. It was 2020 or something. I don't know. During COVID for sure. And then I was doing this one problem for this one course I was taking. It was like a extracurricular course. It wasn't like for school. I was taking like a program. Um yeah, I had this problem. I didn't know anything about coding at all. Other than like print hello world or something like that in Python. And so this problem was really hard for me. I struggled it for like hours. I remember it took me like 3 days. Like 3 days, 6 hours, because I didn't know when to stop, and that was a bad thing. I didn't know when to get help or when to continue doing my own work. But always the rule of if you're having trouble thinking through it for 30 minutes, then it's best that you should stop and get help from someone else so you won't have to struggle as hard as you did, right? So yeah, I looked at the solution to this because I actually didn't know how to solve it, even though like 3 years later, 2023. But yeah, apparently this problem is a dynamic programming problem. I'm not 100% sure what that means, but I know for sure that it's dynamic programming means that you're going to use something that has already been calculated to further ahead to get a solution. So, and it makes sense with this problem. So from here, I'm gonna go through my problem solving process with this problem, and hopefully I'm gonna showcase to you a dynamic programming solution. So let's just go through it. In my problem solving process, I just like to explore the problem. I like to read over it, get the input and output, ask some questions, or maybe get some questions answered. Um, so I'm on the right track. And then after that, I like to give some examples to actually showcase that I do understand the problem. So I can move along and actually solve it, right? And then after that, I like to go over some approaches we can do, and what else? And then once I find the correct approach or approach that works the best, I like to go ahead and plan it, then implement the plan, and then review my code. So yeah, so let's go ahead and do that. So I'm just get up my VS Code. All right, so let's go ahead and read over the problem. So there's a robot on a grid, m times n grid. The robot is initially located at the top left corner, so at 0, 0. The robot tries to move to the bottom right corner, so the length of the grid -1 basically on the row and column, index wise. So and then the robot can only move either down or right at any point in time. And so we're given two integers, so let me just say, so just take some notes. So our input is basically m and n, which is basically row and column. And then our output is that we're going to return unique paths, integer. And we can say for notes, we can say that what is unique paths? Well, unique paths is basically amount of right and amount of paths to reach m minus 1 and n minus 1. Okay. And then we can say, how do we get to end? Can only move left and right. No, down. Can only move down and right. Okay. And we have to start at 0, 0. Okay. Okay, so start at 0, 0. We can only move down and right. Okay. So one thing that I didn't really understand about this problem is that how do we get the unique paths, right? It's very confusing. We can do it by hand. And if you do this, like I remember I did this by hand for like an hour, and then it comes up to 28 paths, right? I can showcase that, but I won't. But let's just say we have like a 2x2 grid, right? We start here, we end here. So there's 1, 2, there's 2 paths, right? But what if we do a 3x3? Okay. Oops, that's not big enough for a 3x3. So if you do 3x3, there's more paths, right? So we can go right, and then right, down, and then down. And then we can go down, go right here. We can go down, we go right here. Then we can go right, then down here, and right, right. But if you see a pattern here, I'm pretty sure you'll see that, okay. So you notice how there's stacking here, right? There's definitely stacking here, right? There's obviously some repeating here that we see. But what I learned is that it's kind of weird to think about it. But usually there's only one path. There's only one path. I mean, there's only yeah, for the bottom and the most right column. For the bottom row, most right column, there's only one way to go because we're all the way down here, right? Yeah, we're all the way down here. And from here, on the right column, we can only go down. So there's only one way to go. But for here, we have two ways to go. We can go down and right. And then the same thing for here. There's only two ways to go. We can go down and right. But one thing we can note is that we can basically add these two numbers, the down and the right. That will basically calculate how many unique paths there are starting from here. It's basically summing it up. So 2 plus 1, that's 3. And then here, 2 plus 1, that's 3. Okay. And now from here, there's three ways we can go. We can go here, here, and yeah, we can go here, through here, and then here, I guess. I don't know, there's a lot of ways we can do it. We're basically adding up the amount of unique paths we can do from each square. According to our constraints of going only down or right. So that makes sense, right? And then from here, where we start, we can basically add up these two. So down and the right, that's 6. So in a 3x3, we can say that there's 6 unique paths, right? That's kind of the algorithm we have. And with dynamic programming, remember how I said that it's basically, in my words, that we're taking whatever we have already and then adding on to it to get to the solution, right? So that's kind of what we're going to do. The algorithm where we take we add the sum of the down and the right to get the square value and then keep on going at every square, right? So that makes sense, okay? And then we're going to take the part, wait, my throat, that's so dry, hold up. Oh my God, sorry. All right, so I got some water. My throat was really dry, but I think I was on the word or sentence of like saying that knowing that there's only one unique path on each squares on the bottom row and on the rightmost column, because they can only go down, right? There's only one way to get to the solution. Then we can use these as foundations for our dynamic programming, right? Solution. It makes sense to me. So I'm just gonna go ahead and code it. So first off, actually let's go over some approaches. So initially, for an approach, when I was first thinking about this, we can do like a depth first search, I guess. Yeah, we can do depth first search maybe. I'm not sure how to do that with this, but yeah. Or we can do dynamic programming, or we can solve it with the math solution. There's a math solution, but that's not really what we're supposed to do, right? Well, DP, we can say that bottom row is equal to 1, and then right column is equal to 1, rightmost. One unique, yeah, they all have one unique path to go to the end. And then what we can do is we can say, okay, so we're obviously going to need to get user input of m and n. And then once we do that, let's do some DP. Okay. So for DP, we're we're gonna go through we're gonna use only one column. That's initialized to 1. So row is equal to n times 1. No, 1 times n. Oops. Because that's the amount of columns there are in that row. And then, as I said before, we're gonna use a DP solution. So we're gonna use this row to basically calculate the result. Like how I did here, where we basically calculated the next row by adding the down and the bottom. I mean the down and the right. So if we do that, so for I in range, going all the way up to excluding last row, right? All the way up to excluding the last row. We're going to make a new row. That's basically the same thing times n. And then to get and then we're going to calculate each column in the row. So for j in range, starting from, we're going to start from m minus 2, because we already know that this column right here is going to be 1. We want to calculate these columns, right? These columns are the ones that matter the most. So m is equal to 3. The last column is -1 index wise. The second last column is -2, right? So that makes sense. So m minus 2, and then we're going to stop at -1 because we also want to calculate 0. But once we hit -1 as an index, then that's when we're going to stop. And then we're going to decrement 1 every time. So basically going in reverse, basically. So we're going to start here all the way to here, right? We're going to stop here. We'll start here and here. Okay. So that's what's going to happen. And then let's see. And then for j in range, so the new row at j, so basically at right here at this 2, we're gonna, to calculate that 2, we're gonna have to do new row j plus 1. So basically right here, this is the +1, and then the one below it, which is row plus row at j. So this is going to be basically the right, this is the down. Okay, that makes sense, right? Makes sense, right? And then I say row plus j because we're going to use this we're going to, at every time we do this, every time we're out of this second loop, we're going to make row equal to new row. So this is going to be so new row. So this is now the row. This was currently the new row. Now we change this to the row. And then the new row would be this, basically. So does that make sense? I think to me it does. But I feel like I'm going to forget this later on if I should get this as a solution. But maybe, I think it's just good to like go through, just to do something new, and then it'll maybe stick if you actually try to learn it. And that's what I'm trying to do right now. So to me, that makes sense because I'm doing it right now. So yeah, we're basically saving our solution. That's why it's a dynamic programming solution, because at every time we're saving it to use to get to the solution. So row equals to new row. And then once we get that, I think at the end, we should be at the point where we're at our last row. And then at the last j, basically at the 0, at index 0, which is right here, when we're at j, it's going to calculate +1. It's going to do the right and the down below it, right, which is the row. This is new row. And so that's what it's going to do. And then we can say, once we're out of the loop entirely, we can just return the row at 0, which is this, which should be 6. So that makes sense to me. Yeah, I should say here, start at second last call, and then reverse. And then from here, what are we doing? We're only get new row above cur row. And then here we gotta return result, basically. Okay. And then I think row equals to new row is the DP part of the problem. So from there, now we have the plan. Let's go ahead and implement it. So my plan is basically the whole code itself, but let's just do it, right? So let me make a function called get paths, get unique paths, I guess. I'm gonna take in m and n. So let's go ahead and get user input. So user m is going to equal to the input, integer input actually. And user n is going to equal to input as well. And then we're going to call get unique paths with user m and user n. And then I know that get unique paths is going to return an integer, so I'm going to print out its return value. Let's go ahead and code unique paths. So it's pretty simple what I did here. So we set row to have a value of 1, and then it's gonna have like n value of 1s in the whole list. And then we're going to calculate every row. So not every row, we're going to calculate to get the result. So for I in range, excluding the last row, so that's basically n-1. So we're only going to do it n-1 times. And then we're going to say new row is going to be equal to the same thing. It's going to have 1s. It's going to have n 1s. And then we're going to say for j in range, starting from the second to last column, so n-2. All the way down to the last element, -1. So in reverse order, basically. We're going to say a new row at j is going to equal to the right, so j plus 1, and then plus the row below it, so we're at j, which is the old row. And then from there, we're going to make the new row. I mean, we're going to make new row the old row. So row is equal to new row now. And then at the end, we're going to have this solution basically, where we're done. And now the row is now here. There's no more new row because we're out of this whole loop in general. So this is the row. And then now we're going to say we're going to return row at 0, 0, which should be this index value, 6. So yeah, that should work. So should return 6 here. So let's just say we have a 3 by 3. Oops. An object is not scriptable. What does that even mean? What does that mean? Hold up. Oh, oh, why is it so loud? I was thinking about a 2D list, but row is basically a 1D list. So yeah, okay, so that should be the whole thing. So I was thinking about this, where it's like 2D, so row and column, but it's just we have one row. Okay, that makes sense. So it should return 6 now. Oops, 3, 3. Okay, cool. So it works. Let's go copy paste this into LeetCode to see if it actually does work. Okay, run. New row at j. Index out of range. Relay. 3 plus 1. In range n-2. Oh, it should be n. That's the columns. There you go. Okay, so it does run. It's not that it's pretty fast. 45 milliseconds is really fast, but not compared to it's only 20 milliseconds different, but it's fine. Let me just change this here. I'm not sure why that worked with that one, but good thing I caught it. Because I knew it shouldn't be out of range at all. So to review the complexities, this is O of n time, because we're going through every element once, basically. Yeah, that's basically it. We're going through every element once. Well, not really, but if it was like a 2D array, that would be true. Um, if it was a 2D array, that would be true. But it still is kind of true. We're going through it like n times m times, I guess. I don't know. I don't even know, man. But for space complexity, it's definitely O times O O of n times m times, because yeah, we're having one row that has size of n, but we're going through it m times because that's the amount of rows that we have, right? So that makes sense. Yeah, I guess time complexity is O of n in general, and because constants don't really matter. So O of n and O of n, O of n time and O of n space.